In this video, we will answer the question how to define the ideal K value, or in other words, the number of subpopulations which should be considered when running the structure software. We will continue our work from the last time, so if you haven't done so far, check out the basic structure tutorial video on this channel. So we want to continue our previous work, so we have to go to File and open the project we were working on previously. After localizing the directory, you click on the SPJ file and click Open. So now our project data and also our previous run is already loaded. This previous example run was just for one K value, but in this video, we want to try out and find out what is the actual ideal K value by screening many of the possible options. For this, the workflow is the following. We create a new parameter set that will serve for our purposes of screening through multiple K values in multiple iterations. These will add up to quite a few number of runs. So for test purposes only, I will use here a very, very low number of iterations for the burn-in and the MCMC. As I mentioned in my previous video, you are very welcome to use these low numbers also for testing. But if you want to get serious results and you want to use these results for a serious purpose, as for publication or thesis, you must use much higher number of iterations. So I go ahead here and enter 10 for the burn-in and then 50 for the MCMC repeats. Hit OK and name this parameter set as quick test. Hit OK, and we have now the second parameter set here. As I mentioned in my previous video, but I couldn't show it at that point. So here now the second parameter set is active. If you want to change back to the previous one, so just right click and say activate here, so it changes back to the previous one. But right now we are more interested in this quick set, so we reactivate this and move further with the processing. If you want to run a series of analysis in structure software, you click Project and Start Job. Here we have a new window where you could set the K values, starting value, and the ending value. So basically, it will run for each of these K values and produce a result file. Also, you can repeat each of the iterations for the K value, which you can set with this number of iterations box. So I go ahead and select our quick test parameter set here just by clicking on it. And we will explore K's from 1 to 9. But this is really just an example here. Of course, the K values you want to explore depend very much on your data. Also, the number of iterations is something that you need to take care about. I will use 3 here just to have this one done in a reasonable time. But again, if you are serious about the results, you need to also use higher number of iterations. We will see a simulation paper in this video, and for example, there they use 20 iterations for each K value. But right now we are set, so we just click Start here. And there is a log window jumping out, and the analysis is already ongoing. So this is fairly quick right now, but just because I used very, very low number of iterations and burning. Still, it will take quite a bit of time, as we will have, I think, 27 runs for the structure software. While this is running, we will check out another resource which we will use to evaluate the results of the structure runs. And this resource is the so-called Structure Harvester software or website. It is very easy to use, as you will see later on, but also here are also the instructions. What should you do? So basically it has 5 points. The 5th point is already that we should enjoy our results, which is great. So anyway, so the first one or the first point is running right now. So run the structure and look at the results folder. We will have that. We will need to zip that and basically upload this zip file here. And then just click harvest. So this is everything. Also, here are the references. So actually the approaches that this website or software uses, and also the citation, how you should cite structure harvester. From here, actually, the most interesting, at least from my perspective, is this Evernote 2005 paper, which is detecting the number of clusters of individuals using the software structure simulation study, published in Molecular Ecology. Now, if you click this link, it will not work, or at least it was not working for me. But if you search for this title, you will find a resource or a PDF that is freely available. This is this PDF, so I suggest you to read through the paper, also to have or acquire a bit more knowledge about the approach. But for this particular video, we will point out some of the figures that we will be seeing later on. Here are 4 figures that will also appear in the Structure Harvester website. So it's actually good to look at them first, or on the simulation study first, so to see what to expect and what to look for. The figure description is quite helpful, and actually it says that it describes the 4 steps for the graphical method allowing the detection of the true number of groups. Now, in this particular case, or in this simulation study, the true number of groups was 5. So you see that this is actually indicated here. And also in this first graph, the LK, so basically the values start to flatten out starting with 5. The second graph, so there is a big drop at 5. Graph C, so there is an elevation and jumping out, so the value in this graph is somewhat higher than the others. And delta K from graph D, here you see that there is a much higher delta K value for the true value of the number of subpopulations that we are looking for. So in your results, you also have to look at these 4 figures and have to look for similar clues to determine the K value for your particular population after you used a sufficient number of burn-in and MCMC, and also a sufficient number of repeats for each of the structure runs. We go back to structure and see that it's still running. So here are our results, and it's actually produced quite a bit. So 17 runs are already done. But right now we are at the K value 6. So we go until K value 9, because this is how we set it. So we wait. And we already finished. Wasn't it even that long? Was it? So we get a neat little job is completed message. So we click OK here, and we move forward to process the results in the structure harvester. According to the instructions, we will zip the results folder. You remember our parameter set is called quick test. So we enter here, and here is the result folder we are after. And in it, there are the results for each of the 27 runs that we have done. You can, of course, open these with any text editors and see what's inside. So basically, these are all the descriptions and all the details about the populations we are analyzing. But we move forward and try to find out what is the best K value. What we need to do is zip this results folder. So we go ahead and, I use 7-zip, which is, I believe, a freely available software. So if you don't have any zip program, you can go ahead and download this. We say add to archive, and here we will create the result zip. By default, this is set to 7Z here, but if you just change this archive format to zip, then everything is as expected. Click OK, and it zips it together for us. The zip file is here, so right now it has 35 megabytes. I want to note that if you want to use the online version, it has a limit of 50 megabytes. If your zip file is more than this, then you need to use the standalone version of the Structure Harvester. So we move to the Structure Harvester website and upload the data. I have German localization here, so that's why it's different for me here, but for you, it will be something like select data or select files or similar. We select the compressed results.zip file that we just created and click harvest. The data needs to be uploaded, so this also will take some time and perhaps also depending on your internet speed a little bit. And of course, the size of the file. When the data is uploaded, the results are generated fairly quickly, and we will see the 4 graphs I was talking about. So this is the LK, the L prime K, and the others. Here, even the paper is mentioned, and you can click various links if you want to know more about these estimation methods. Here, it seems that we have 3 subpopulations, so the ideal value for us would be 3, according to the previous graphs, but really the major one or the very clear signals coming from this last graph from the delta K. I hasten to add, however, that still the notes that I made previously, namely that a sufficient number of iterations, burn-in, and replicates needs to be done before we can conclude anything major from these results. But this is okay for now for this demonstration video. Of course, now that we know that our best K value is 3, for this particular example, we can go back to structure. In the structure software, then we could look up what are the graphs and the exact values for the K equals 3, which is supposed to be the best estimate for our populations. I hope this video was helpful for you. If yes, leave a like. If you are not subscribed, leave a subscribe. But in any case, I thank you for your time you spent on this channel with this video, and I wish you a very nice day.